I am Carl Clarence Licaros, and today I will work on Quarter 1, Module 5, Evidences of Plate Movements.
And before I go to the discussion, first, I will answer the pre-assessment. Directions. Choose the best answer in each item. Write your answer in your answer sheet. Number 1. What evidences do the scientists use to support the continental drift theory? Letter B. Rocks, water, ice. Number 2. The youngest crust is found blank the mid-ocean range. I think letter B. Near. Number 3. If you are a cartographer, what would give you an idea that the continents were once joined? I guess letter A. Ocean depth. Number 4. Discovery provided strong support for continental drift theory. Letter A. Geology. Number 5. Which is not evidence of seafloor spreading? I believe letter B. Drilling samples of rock. Number 6. The magnets point north when Earth's magnetic field is blank. Letter D. Normal polarity. Number 7. Why was Alfred Wegener's continental drift theory not accepted immediately by the people during his time? I think letter C. He described that the rocks and mountains at the edges of the continents were similar. Number 8. Why were magnetic patterns found on the ocean floor puzzling? Letter A. They did not show alternating bands of normal and reverse polarity. Number 9. What do you call the process that forms new oceanic crust? I believe letter D. Trenching. Number 10. What do you call the supercontinental landmass formed million years ago? Letter A. Pangaea. Number 11. If Australia is moving about 2 cm per year and was drifted from the ridge by 1,000 km, how long was it when Australia was near the ridge? Letter A. 50 million years. Number 12. Which one among the continental drift pieces evidence mainly proves that Cape Mountains of South America and Africa line up perfectly before? Letter D. The climate of the two continents is almost the same and with the same ancient organisms. Number 13. What information can derive about Antarctica having fossils of ancient plants and animals? Letter A. Antarctica drifted from southern hemisphere because of melting glaciers that traps the plants and animals. Number 14. He is a German scientist who hypothesized in 1912 that continents were once giant landmass called Pangaea. Letter C. Alfred Luther Wegener. Number 15. What did Harry Hammond Hess realize in the 1950s when his team continued exploring the ocean floor and discovered the mid-Atlantic ridge? Letter A. He realized that the oceanic crust is older than the continental crust. And now I will read the discussion part. Continental drift theory. Alfred Luther Wegener was a German polar researcher, geophysicist, and meteorologist. He is remembered as the originator of the continental drift theory by hypothesizing in 1912 that the continents are slowly drifting around the Earth, and is once a large landmass called Pangaea, a Greek word which means all Earth. The coastline of some continents appear to fit together like a jigsaw puzzle. Over tens of millions of years, Pangaea began to break apart, moving the continents to their current location as seen in the picture. Would fitting edges of the continents be enough to prove that the continents are drifting? What are the other pieces of evidence gathered by Wegener to support his continental drift theory? Here are some evidences. First, the geological fit evidence. According to the module, it is a matching of large-scale geological features in different assemblages across different continents. It has been noted that the coastline of South America and West Africa seem to match up. However, more particularly, the rock terrains of separate continents confirm as well. Second, the coal deposits. It is said that Antarctica might have been positioned in a part of Earth where it once supported large quantities of life. This leads to the idea that Antarctica once experienced a tropical climate, thus it might have been closer to the equator. Third, the glaciers. Glaciers are carved rocks and leave marks as they move. In this evidence, scientists can determine the direction of movement of each continent. And last evidence to the continental drift theory is the fossil evidence. It can be also considered as evidence because there are various examples of fossils found on separate continents and in no other regions. Kuya, hello. Can you help me in this part?
Sure thing. First, let me discuss to you the Mesosaurus. The Mesosaurus is known to have been a type of reptile similar to the modern crocodile, which lived during the early Permian period, and its remains are only found solely in South Africa and eastern South America. The second fossil is the Sagnonotus, which was a mammal-like reptile. This roaming the terrains during the Triassic period, which is 250 to 240 million years ago. This creature was as large as a modern wolf. Its fossils are only found in South Africa and South America. Third, Lystrosaurus, which translates to shovel reptile, is thought to have been an herbivore with a stout build like a pig. Its fossils are only found in Antarctica, India, and South Africa. Similar to the land-dwelling Sagnonotus, the Lystrosaurus would not have had the swimming capability to traverse any ocean. Lastly, the Glossopteris. It is the most important fossil evidence found in the plant, and it also known as a woody, seed-bearing tree. The Glossopteris fossil is found in Australia, Antarctica, India, South Africa, and South America, all the southern continents. Glossopteris seed is known to be a large and bulky and possibly could not have drifted or flown across the oceans. Therefore, the continents must have been joined at least one point in time in order to maintain the Glossopteris.
Thank you so much, Kuya, for explaining it to me. I will now do the activity 1, a journey from the past to the future. Cut out carefully the picture of the land masses. These cut-out land masses represent the continents and some of the large islands of the Earth 100 million years ago. In the drawn circle, in a separate sheet, construct the supercontinent using the legend as your basis. After performing the activity, I will now answer the guide question. Question number 1. The Glossopteris fossils tell us all land masses were once joined together? Yes, due to the fact that the fossil is known to be large and bulky and possibly could not have drifted or flown across the oceans to a separate continent. Question number 2. If Glossopteris fossils were found in Antarctica, what was the climate of this continent before? I think the climate of Antarctica was temperate. If the climate and the position of a place were relative to each other, where then was the initial location of Antarctica 250 million years ago? I certainly believe that the initial location of Antarctica 250 million years ago is near the equator. Question number 4. Is the presence of animal fossils tells that South America, Africa, and Antarctica were once connected? Yes, the presence of animal fossils tells that South America, Africa, and Antarctica were once connected. What clues are useful in reconstructing Pangea? The clues that were useful in reconstructing Pangea are fossils, shapes, rocks, and sand. Which continent were obviously neighbors before? The continents were obviously neighbors before are South America and Africa. Question number 7. Where do you think was the location of the Philippines in Pangea during the time when it existed? The Philippines didn't exist during this time. Question number 8. If the continents will continue to move, try to predict the Philippines location 25 million years from now. I think the Philippines might be moving eastward. And now, I am going to do the assessment number 1. Number 1. He was credited to the idea of continental drift theory. The answer is letter A, Alfred Luther Wegener. Number 2. All continents were once joined together, forming a supercontinental called blank. Letter D, Pangea. Number 3. It is possibly the most important fossils plant evidence that continents are drifting. I think it's letter A, Glossopteris. Number 4. What are the evidence gathered by Alfred Wegener to support the continental drift theory? I believe letter A, continental feet, rocks, fossils, coal deposits, ancient climate, and glacier scars. Number 5. What two specific continents fit together most noticeably? I guess the answer is letter B, South America and Africa. I am going to call again my mother to check the assessment that I have answered. Ma, can you help me?
Of course, anak. Wait, let me check the answer key. The correct answer in number 1 is letter A and you choose the correct answer. Very good, anak. In number 2, the correct answer is letter D and you also choose the correct answer. The number 3, the correct answer is letter A and you put also the correct answer. It's very good, anak. In number 4, the correct answer is letter A and you choose also the correct answer. In number 5, the correct answer is letter B and you also got it correct. Congrats, anak. You perfect the first assessment test. Keep up the good work. If you have any question, just call me, okay?
And now, at this point, let's go to lesson 2, which is seafloor spreading theory. The idea of the continental drift circulated in scientific circles until World War II, when the sounding gear called sonar produced new evidence of what the seafloor looked like. It happened that the command of one attack transport ship, the USS Cape Johnson, was given to Harry Hammondus, a geologist from Princeton University. Let's get to know more about the discoveries of Harry Hammondus. Ocean floor exploration continued, and by the 1950s, other researchers had found that a huge reef ran along the top of the mid-Atlantic ridge. He then discovered the bottom of the sea was not as smooth as expected, but full of canyons, trenches, and volcanic sea mountains. He also realized that the Earth's crust had been moving away on each side of that oceanic ridges, down the Atlantic and Pacific Oceans, long and volcanically active. Observed that the rate of the formation of new seafloor and the mid-ocean ridge is not always as fast as the destruction of the old seafloor at the subduction zone. To further understand this, let us search and explore using Google.
Okay, let's start by looking at the pieces we're going to be examining in this example. First up is the Earth's crust, which is made up of the Earth's tectonic plates. We will be looking at 3 plates in this example: the North American plate, the Juan de Fuca plate, and the Pacific plate. And then there's the Earth's mantle, an area that lies just beneath the Earth's crust. On the Earth's surface, this material is called lava and is liquid because it is so hot. But below the Earth's crust, incredibly high pressure keeps this material in a kind of semi-solid state, so it moves like very thick peanut butter would. So we have the North American plate, the Juan de Fuca plate, the Pacific plate, and the Earth's mantle. This process begins with mantle material welling up due to convection. The upwelling of mantle material pushes up in between the plates. This pushes the plates apart. This mantle material that reaches the sea floor becomes new plate material. In our case here, the Juan de Fuca plate moves to the east and the Pacific plate moves to the west. Megathrust earthquakes can only occur in places where a plate is pushed under another plate. This process is called subduction. Earthquakes that occur because of this process are the only known earthquake type we know of that can cause a 9.0 or greater earthquake. It is because of this that most megathrust earthquakes cause large tsunamis. Here we have the Juan de Fuca plate being subducted under the North American plate. As it subducts under the North American plate, it causes the lip of the North American plate to get pulled back. The motion continues until the 2 plates get stuck. Pressures build up until the plates slip. This is the earthquake. In this case, the lip of the North American plate will flip back up as the pressure is released. It is this flipping back up of the plate that pushes the water above it up, causing a tsunami.
Oh, now I know. That was an informative video. And now, let's do activity 2, where it all begins. This is the figure 1, which is the ages of oceanic lithosphere in million years. Guide question number 1. What type of plate movement or boundary is happening in the mid-Atlantic ridge? I think the type of plate movement or boundary is happening in the mid-Atlantic ridge is divergent boundary. Question number 2. Before question number 1, what molten material will come out from the ridge? Magma or lava, because we all know that the mantle is underneath it. Question number 3. What can you say about the ages of oceanic rocks near the mid-Atlantic ridge? The oceanic rocks near the mid-Atlantic ridge is younger. Question number 4. What can you say about the ages of oceanic rocks far from the mid-Atlantic ridge? The oceanic rocks far from the mid-Atlantic ridge is older, while on the other hand, the figure above shows the cross-section of mid-Atlantic ridge and oceanic crust. Question number 5. What can you say about the thickness of the sediments near the ridge? Based on the figure, the sediments near the ridge is thinner. Question number 6. Before question number 5, what can you say about the density of rocks near the ridge? I think the density of rocks near the ridge are less dense. Question number 7. What can you say about the thickness of the sediments far from the ridge? The sediments far from the ridge is thicker, and I think this is due to the frosted magma. Question number 8. Prior to question number 8, what can you say about the density of rocks far from the ridge? The density of rocks far from the ridge is denser. Let's move on the diagram above, which shows the movement of oceanic crust in the mid-Atlantic ridge and the different geologic process involved. Question number 9. If new ocean floor is being formed near the ridge, what will happen to the old oceanic crust materials? I think the old crust is pushed back into deep sea trenches. Question number 10. What is the importance of the seafloor spreading in understanding the origin of plate movement? Seafloor spreading is a process that occurs mid-ocean ridges where new oceanic crust is formed through volcanic activity and gradually moves away from the ridge. Question number 11. Based on your understanding about the seafloor spreading theory, is Earth getting larger and wider than the plate drift away from each other? No, the Earth doesn't get larger and wider as plates drift. And now, let me answer the assessment 2, which is all about the seafloor spreading. Number 1. What can you say about the ages of oceanic crust near and from the mid-oceanic ridge? The answer is letter A. Oceanic crust is younger near the ridge but older far from it. Number 2. During the World War II, he discovered and proposed that the origin of the plate would be at the mid-oceanic ridge. I will answer letter B. Harry Hess. Number 3. Describe the thickness of the sediments near and far from the mid-oceanic ridge. It's letter A. The sediments are thinner near the ridge but thicker as far as you go far from it. Number 4. What type of plate boundary is occurring the mid-Atlantic ridge? Letter C. Divergent plate boundary. Why is the Earth not getting bigger despite the fact that molten materials are gradually coming out from mid-oceanic ridge? My answer is letter C. The older oceanic materials are pushed away and slowly consumed in subduction zone.
Now let me check your answer in assessment 2. Okay, the answer in number 1 is A, you're correct. In number 2, B, you're also correct, very good. In number 3, letter A, you're correct. In number 4, letter C, your answer is correct also. In number 5, the answer is letter C. You're correct also. So you got all the 5 questions correct. Very good, Casey.
Thank you, Ma. Let's move on to the last lesson of this module, which is all about magnetic reversal. Magnetic reversal is also known as magnetic flip. Further evidence came along by 1963, as the geophysicists realized that the Earth's magnetic field has reversed polarity many times, with each reversal lasting less than 200,000 years. The Earth has magnetic field, as can be seen by using a magnetic compass. It is mainly generated in a very hot molten core of the planet and has probably existed throughout most of the Earth's lifetime. The magnetic field is largely that of a dipole, by which we mean that it has one north pole and one south pole. Magnetic reversal happens when the North Pole is transformed into the South Pole and the South Pole becomes the North Pole. To further understand this, I will watch some videos on the internet.
Hi everyone. We're going to talk about the Earth's magnetic field and how the reversals in the Earth's magnetic field revealed that seafloor spreading is happening. The Earth's magnetic field creates lines of invisible force that you can't see, but that your compass needle senses. And the reason your needle points north is that these field lines emerge from the south magnetic pole and wrap around and point toward the north magnetic pole. Now, we know that the Earth's magnetic field has actually reversed, flipped around, so that these arrows would all point the other direction, coming out of the north and pointing into the south pole. And these are called magnetic reversals. They happen every few million years. The Earth's magnetic field flips back and forth through time. The reason we know this is that lava flows, like this lava flow on Hawaii, when lava flows out of the Earth, it actually, there's little magnetic minerals in the lava, and they line up with the magnetic field at the time and actually preserve, like a tape recorder, the direction of the Earth's magnetic field, whichever way it was pointing, either normal or reversed. So if we go look at a whole series of lava flows, what we'll find if we sample through the lava layers into older and older layers, we'll find some layers that are oriented with a magnetic field, say like today, and other layers, older layers that are reversed, and then still older layers that are like today. So through geologic time, the Earth's magnetic field flips back and forth, and we call these magnetic polarity reversals. Now, the way that this all relates to seafloor spreading can be realized by remembering that lava is pouring out of the Earth at mid-ocean ridges. Okay, so I want you to imagine that we're going to let this ocean basin spread, and we're going to let the Earth's magnetic field flip back and forth as the ocean basin spreads. Remember that when the lava erupts and cools down, it records the direction of the magnetic field at the time, whether it's normal or reversed, backwards or forwards. So we'll start the animation here. We're going to start it at a time when the Earth's magnetic field is like today, what we call normal polarity. And as the seafloor spreads, it's all going to get polarized in the direction of the magnetic field, shown by the blue part of the ocean floor. But now we have a reversal happening, and any new lava that erupts is going to get magnetized in the opposite direction. So you can see the little compass needles here have flipped, showing us that all this new seafloor is recording the direction of the Earth's magnetic field at a time when it was reversed. Now we'll let the Earth's polarity flip again. Any new lava that forms is going to record the polarity of the Earth at that time. So what we see on the mid-ocean ridges of the world today is a series of stripes, symmetrical stripes on both sides of the ridges of seafloor rock that's magnetized in the same direction as the magnetic field today, older rock that's reversed, still older rock that's back to normal. This pattern is impossible to explain if seafloor spreading didn't actually happen and the Earth's magnetic field didn't flip back and forth. So it constitutes some of the best evidence we have that the seafloor is actually spreading over geologic time.
And now, I will do activity 3, the enigmatic magnetic reversal. Let's find out. What is magnetic reversal? This diagram that shows Earth's magnetic polarity. Question number 1. If magnetic reversals are recorded in the seafloor, what kind of rock is the seafloor made? The kind of rock which seafloor is made are rocks containing irons. Question number 2. What does the magnetic stripes pattern represent? The magnetic stripes pattern represents the direction of Earth's magnetic polarity. Question number 3. Is the magnetic stripe pattern on each side of the oceanic ridge equal? Yes, I think the magnetic stripe pattern on each side of the oceanic ridge is equal. Question number 4. Are the edges of rock on each side of ridge the same? I believe the edges of rocks on each side of the ridge is the same. And now, let's move forward in answering the what I can do part. Activity Pangaea Ultima, the last supercontinent. This picture shows the tectonic process. It's time to answer the guide questions. Question number 1. What can you say about the climate of this supercontinent? I think Pangaea was a hot house then. Temperature were about 20 degrees Celsius hotter in the summer because it is centered in the equator. Question number 2. Do movements of continents play an important factor in the so-called climate change? tectonics cause climate factors. Because there are less greenhouse gases, less heat is trapped in the Earth's atmosphere. To put it another way, tectonic forces, the moving and colliding of Earth's tectonic plates, could cause climate change. Question number 3. Will this new supercontinent be inhabitable for mankind? I think it isn't livable because the entire continent collided and began to form a new supercontinent, and because people are likely to perish as a result of the collision. Just for fun, if you can name the supercontinent, what will it be? Why? I will name it as Colossus-tinent, from the word colossal, which means huge, and from the word continent. After the lesson about the magnetic reversal, I will now answer the assessment number 3. Directions. Write true if the statement is correct, and false if the statement is incorrect. Number 1. The iron materials found in the seafloor can give information about the Earth's magnetic field direction. I think the answer is true. Number 2. The age of rocks that comes out and flow from the east side of the oceanic ridge is equal. It is true. Number 3. The magnetic polarity of the Earth remains normal and does not reverse or change. False. The average distance traveled by the materials from each side of the ridge is the same. True. Number 5. The magnetic reversal happens many times in the past. I believe it is true. And now, let me call on my mother to check my answers.
Here I am, anak. Let me check your answer based on this answer sheet. The answer in number 1 is true and you are correct. In number 2, the answer is true and you also got it correct. In number 3, the answer is false and you also choose the correct answer. Very good, anak. In number 5, the answer is true and you are also correct. You got again the perfect score, anak. Congratulations. And now it's time for you to answer the final assessment that will assess your knowledge in the lesson 3. Good luck. If you have any question, just ask me, okay?
I will now answer the post-assessments regarding the 3 lessons. Number 1. The idea proposed by Alfred Wegener to explain the continental shapes and positions is known as blank. The answer is letter B, continental drift. Number 2. Examine the figure on right, which 2 are the best examples of different continental positions in the past. Letter D, South America and Africa. Next is number 3. In the mid-1900s, scientists mapped mid-oceanic ridges using what? It's letter D, sonars. Number 4. Early observers thought continents might have been joined based on the observation. Letter A, rocks and fossils. Wegener suggested that coal beds discovered in Antarctica indicate that this continent was, its letter B, once near the equator. In the figure, what is the age of the seafloor of the Bahamas? I think it's letter D, 83.0 to 141.9 million years. Number 7. In the figure, what is the approximate age of the seafloor of the north coast of Spain? Letter C, 33.0 to 83.0 million years. We are scientists reviewing Wegener's hypothesis of continental drift rejected this notion because letter C, his evidence was not clear in showing how continents were joined. Number 9. Blank helped explain why Earth is not getting any larger even though the tectonic plates are always moving. Letter C. Also the subduction zones. Number 10. If there are more mid-ocean ridges than subduction zones, what happens to the ocean? Letter A. It gets larger. Number 11. What two Asian glacier scars found in the rock surfaces of Africa tells about the climate in the past? I think it's letter C. Africa was once in the area of the earth and had a very cold climate. Number 12. Which of the following increases the width distance from the mid-oceanic ridge? Letter D. All of the above. Number 13. The seafloor spreading theory states that blank. Letter D. Hot and less dense material from below the Earth's crust rises towards the surface of the mid-oceanic ridge. Number 14. What can you say about the rate of movement materials coming out from the mid-oceanic ridge and the materials sinking in the subduction zone? I think it's letter B. The movement of the materials in both ridge and subduction zone is the same. Number 15. What strong evidence discovered by our scientists that Earth's magnetic reversal had been happening in the past? It's letter A. The magnetic reversal occurrence is supported by magnetic patterns in magnetic rocks found on the ocean floor. Ma, can you help me again in checking my answers?
Sure thing, anak. Let me check it according to this answer key. Okay, let me see your answer. In number 1, the answer is letter B and you choose it correct. In number 2, the answer is letter B. You got also the correct answer. In number 3, the correct answer is D and you choose it also the correct answer. In number 4, the answer is D, but you choose the wrong answer. So you have to read again this question in number 4 and see what mistake you have done. In number 5, the correct answer is B and you choose also the correct answer. Very good, anak. In number 6, the correct answer is D and you choose also the correct letter answer. In number 7, the correct answer is D, but you choose it wrong. So you have to read again this question. In number 8, the correct answer is letter B and you choose also the correct answer. In number 9, the correct answer is C. You are also correct. In number 10, the correct answer is A. Okay, you choose it correctly. In number 11, the correct answer is C. Your answer is also the same. It's correct. In number 12, the correct answer is D. And also you choose the correct answer. In number 13, the correct answer is D. Okay, you choose it also the correct answer. In number 14, it is letter C, but you choose the wrong answer. So read again this question, anak. In number 15, the correct answer is A, and you got it correct. So I think it's good. The total number corrected here in this post-assessment is 11 out of 15. Although you did not get the perfect score, I can still see that you learned, because from the score of 5 from the pre-assessment to the score of 11 from the post-assessment, always remember that you don't have to be perfect in every assessment. The most important thing is that you gain knowledge from every topic. I'm still proud of you, anak. Okay? Keep up the good work.
And that's the end of this module. Thank you, stay safe, and God bless.